So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter solar radiation, heat balance and temperature from the book NCERT Fundamentals of Physical Geography. So let's get started with the question number 1. These questions will be very much important for your upcoming KVS NVS interview. So let's get started with the question number 1. What do you mean by insolation? So insolation means incoming solar radiation received by the earth. The earth receives most of its energy from the sun in the form of short wave radiation. However, not all the incoming solar radiation reaches the earth's surface. A part is reflected, a part is scattered and another part is absorbed by the atmosphere. Only the remaining part reaches the earth's surface. The amount of insolation is not the same everywhere. It varies with latitude, season, time of the day and angle of incidence of sun rays, length of the day and transparency of the atmosphere. For example, at noon in June, Delhi receives more insolation than it does in December because the sun rays are more direct and the day is longer. Therefore, insolation is the primary source of energy for all atmospheric processes including temperature, pressure, winds and hydrological cycle. Next question, why does the amount of insolation vary from place to place? So, amount of insolation varies because of rotation of the earth, angle of incidence of the sun rays, length of the day, transparency of the atmosphere and configuration or aspect of the land surface. Among these, angle of incidence is the most important factor. Vertical rays concentrate solar energy over a smaller area, whereas slanting rays spread the same energy over a larger area. Therefore, vertical rays produce higher temperatures. For example, Singapore receives much higher insolation than the Greenland because sun rays are nearly vertical near the equator. Hence, latitude largely controls the spatial variation of insolation on the Earth's surface. Next question, why are sun's vertical rays more effective than slanting rays? So, vertical rays pass through a shorter thickness of the atmosphere and are concentrated over a smaller surface area. Slanting rays travel through a longer atmospheric path. Because slanting rays travel through more atmosphere, more scattering occurs, more absorption occurs, more reflection occurs. Hence, less energy reaches the Earth's surface. For example, at the equator, afternoon temperatures are generally much higher than the high latitude regions because the sun rays are almost overhead. Therefore, the angle of incidence directly influences the intensity of insolation. Next question, if the earth is closest to the sun in January, why is January colder than July in northern hemisphere? So, earth is nearest to the sun in perihelion position around 3rd January and furthest aphelion position around 4th July. However, seasonal temperature is mainly controlled by the tilt of earth's axis, not by the earth-sun distance. During January, the north hemisphere is tilted all away from the sun. As the sun rays are slanting, the days are shorter, insolation is lower, hence winters occur. For example, India experiences winter in January even though the earth is closest to the sun. Therefore, axial tilt is much more important than the earth-sun distance in determining seasons. Next question, can you explain the heat budget of the earth? So, earth maintains balance between incoming solar radiation and outgoing terrestrial radiation. This balance is known as heat budget of the earth. So, out of 100 units of incoming solar radiation, about 35 units are reflected back to the space as planetary albedo. About 65 units are absorbed by the earth atmosphere system. The absorbed energy is later emitted as long wave terrestrial radiation, maintaining equilibrium. So, if the balance is disturbed, the earth will either continue warming or continue cooling. Fortunately, the earth's heat budget remains nearly balanced over long periods. For example, the Earth's average temperature remains relatively stable because incoming and outgoing energy are nearly equal. Hence, the Earth's heat budget is the basis of global energy balance and climate system. So next question, what is planetary albedo and why is it important? So planetary albedo is the percentage of incoming solar radiation that is reflected back to space by the Earth's atmosphere, clouds and surface without being absorbed. So about 35% of incoming solar radiation is reflected back to the space. So the reflected energy does not contribute to heating of the Earth. A higher albedo means less absorption of solar energy, while a lower albedo means greater absorption and higher temperatures. Snow, ice and thick clouds have high albedo, whereas forests and oceans have relatively low albedo. For example, fresh snow reflects much more sunlight than a dense forest. Therefore, snow-covered regions remain cooler because they absorb less solar energy. So, planetary albedo is one of the major controls of the Earth's heat budget and global climate. Next question, why does the atmosphere absorb only a small part of incoming solar radiation? So the atmosphere is largely transparent to shortwave solar radiation. Therefore, most incoming solar radiation passes through the atmosphere and reaches the Earth's surface. So only a small portion is absorbed by gases such as ozone, water vapor and dust particles. The Earth's surface absorbs much more solar energy than the atmosphere. As a result, the atmosphere is mainly heated indirectly from below, not directly by the sun. For example, on a clear winter morning, sunlight passes through the atmosphere easily, but the air remains cold until the ground becomes warm. So this explains why the Earth's surface acts as the principal source of atmospheric heating. Next question, what is terrestrial radiation? So after absorbing solar energy, the Earth becomes heated and emits energy in the form of long wave radiation. This outgoing energy is called terrestrial radiation. So unlike the incoming solar radiation, terrestrial radiation has a longer wavelength. The atmosphere absorbs a large part of this outgoing long wave radiation through greenhouse gases such as water vapor and carbon dioxide. For example, after sunset, the Earth's surface continues to lose heat by emitting terrestrial radiation. So terrestrial radiation is responsible for maintaining the Earth's energy balance. Next question, why is the atmosphere heated more from below than from above? So the atmosphere is heated mainly by terrestrial radiation, not directly by the solar radiation. Solar radiation first heats the Earth's surface. The heated surface then transfer energy to the atmosphere through conduction, convection, terrestrial radiation and latent heat. Therefore, the lower atmosphere becomes warmer than the upper atmosphere. For example, during the daytime, the ground becomes hot first, then the air in contact with it becomes warm. Hence, the atmosphere is primarily heated from below. Next question, differentiate between short wave radiation and long wave radiation. So short wave radiation originates from the sun and long wave radiation originates from the earth. Short wave radiation high energy and long wave radiation lower energy. Short wave radiation has short wavelength and long wave radiation has long wavelength. So short wave radiation passes easily through the atmosphere and long wave radiation mostly absorbed by greenhouse gases. Short wave radiation heats the Earth's surface and long wave radiation heats the atmosphere. For example, sunlight entering through a glass window represents short wave radiation. The warmth felt inside the room later is due to long wave radiation emitted from the heated floor and walls. So the interaction between short wave and long wave radiation forms the basis of Earth's heat budget. Next question is explain the process of conduction and why is it important in atmospheric heating. So conduction is the transfer of heat from a warmer body to a colder body through direct contact without movement of the material itself. In the atmosphere, conduction occurs when the Earth's surface heated by solar radiation transfers heat to the air in direct contact with it. Conduction is effective only in lower layers of atmosphere because air is a poor conductor of heat. As we move upward, the air is no longer in direct contact with the Earth's surface, so conduction becomes less effective. For example, on a sunny afternoon, the road becomes hot first. The air touching the road also becomes warm due to conduction. Therefore, conduction initiates atmospheric heating, but its effect is confined mainly to the lower atmosphere. Next question, why is conduction confined only to the lower atmosphere? So conduction requires direct contact between bodies, between two bodies. So only the air immediately above the Earth's surface remains in direct contact with the heated ground. As the distance from the surface increases, the contact is lost. Moreover, air is a poor conductor of heat. Therefore, conduction is limited to the lower few meters of the atmosphere. For example, the air near the ground usually warmer than the air on the roof of a tall building during daytime. Hence, conduction alone cannot heat the entire atmosphere. Next question, explain convection and why is it more effective than conduction. So convection is the vertical transfer of heat through the upward movement of warm air and the downward movement of the cooler air. So when air near surface becomes warm, it expands, becomes lighter and rises. Cooler, denser air moves downward to replace it. This continuous circulation transfers heat vertically. Unlike conduction, convection can heat a much larger part of the troposphere. For example, during summer afternoons, warm air rises from the agricultural fields forming convective currents which may later produce clouds and thunderstorms. So convection is the dominant mechanism of vertical heat transfer in the troposphere. Next question, differentiate between conduction and convection. So in conduction heat transfer by direct contact, and in convection heat transfer by vertical movement of air. So in conduction no movement of material is happened, and in convection air itself moves. So conduction process is effective only near the Earth's surface and convection is effective throughout the troposphere. Conduction is a slow process and convection is a faster process, and conduction is limited role in atmospheric heating, and convection process has a major role in atmospheric heating. For example, the air touching a heated road becomes warm by conduction, while the warm air rising upward is a convection. So both processes work together, but convection distributes heat more effectively through the atmosphere. Next question, what is advection and why is it important in weather? So advection is the horizontal transfer of heat by the movement of air masses from one place to another. For example, unlike convection which is vertical, advection transfers heat horizontally. It redistributes heat between oceans and continents and between tropical and polar regions. Advection strongly influences regional weather and climate. For example, during summer, hot and dry winds or loo blow from Thar Desert to northern India through advection, causing a sharp rise in temperature. So advection is responsible for the horizontal redistribution of heat and plays a significant role in weather changes. Next question, differentiate between convection and advection. So convection is a vertical movement of air and advection is horizontal movement of air. Convection transfers heat upward and advection transfers heat sideways. Convection produces clouds and rainfall. Advection produces regional weather changes. Convection is a local process and advection is regional to continental process. For example, warm air rising over central India is convection, whereas the movement of monsoon winds across India is advection. So convection controls vertical heat transfer, whereas advection controls horizontal heat transfer. Next question, what is latent heat and why is it important in the atmosphere? So latent heat is the heat absorbed or released during a change in the state of water without any change in temperature. So during evaporation, water absorbs latent heat from the surroundings. When the water vapor condenses into cloud droplets, the stored latent heat is released into the atmosphere. This released heat strengthens atmospheric instability and weather systems. For example, during monsoon, condensation inside clouds releases latent heat, which helps thunderstorms grow stronger. So latent heat is a major source of energy for cloud development and tropical cyclones. Next question, which heat transfer process is most important for cloud formation? So convection and latent heat release together are the most important processes for cloud formation. So warm moist air rises by convection. As it rises, it cools and condenses. During condensation, latent heat is released, providing additional energy for a further uplift. For example, cumulonimbus clouds during pre-monsoon thunderstorm develop through convection and latent heat release. Therefore, convection initiates cloud formation while latent heat intensifies it. Next question, why is the troposphere the warmest atmospheric layer? So the troposphere is heated mainly from below by Earth's surface. So the Earth's surface absorbs solar radiation and transfers heat upward through terrestrial radiation, conduction, convection and latent heat. Since these processes operate mainly in the troposphere, it contains most of the atmospheric heat. For example, almost all weather phenomena occur in the troposphere because it is the warmest and most active layer. Hence, troposphere is the most dynamic layer of the atmosphere. Next question, and this is the last question for today. Suppose convection suddenly stopped, what would happen to the atmosphere? So convection is the principal mechanism of vertical heat transfer in the troposphere. So if convection stopped, heat would remain concentrated near the Earth's surface. The upper troposphere would receive much less heat. Cloud formation and rainfall would decrease significantly. Atmospheric circulation would weaken. Weather system would become much less active. So, for example, without convection, towering cumulonimbus clouds and many thunderstorms would not develop. Therefore, convection is indispensable for maintaining atmospheric circulation and weather over the earth. So, thanks for listening. Keep listening for further audio classes. Thank you.